Hello, 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 Kevin here, and welcome back to another episode of Kerbal Space Programming, where we do all of our space things without using any manual controls, all scripted. Now, in the past several episodes, we've talked a lot about various software techniques. We've talked about designing things in small functions, we've talked about pipelines, we've talked about function delegates and why they are particularly cool. But there's a problem that can come along with focusing too much on these sort of programming strategies, and that is that we can come up with an absolutely fantastic and amazing solution to a problem that we don't have. What we haven't been doing is actually writing scripts based on missions that we want to accomplish. And so that is what we are going to do now. I've gone ahead and preemptively named ourselves a craft called Athena Mark 1. We are going to start our own series of missions named after Greek gods, because that's what we do here in America, because Neil Gaiman hadn't written American gods, so NASA had to go with the Greek ones. We're going to have the Athena missions, which are going to be to get us to the surface of Minimus and back, because that is our goal. We kind of need to get some more science. We're kind of capped out, and we don't have the larger rockets, which kind of limits some of what we're able to do. We could expand some stuff, but really that's where we want to get next. And so want to start setting up some missions that'll really get us to the next phases of where we want to be. And so what I want to try and do today is start off on, I guess let me describe what the overall goal is, and that is that I want some craft to be able to get from the launch pad out to Minmus, it to be able to land, run some science, and return with that science safely. So it's going to mean a powered descent on Minimus. It's going to mean probably an unpowered descent on Kerbal. And of course, if we're going to think about that, well, the first thing that we should think about, because rockets happen in reverse, is what is the thing that should come down back to Kerbal? And the very simplest thing would be something that has a parachute. Come on, parachutes. Give me a parachute. Yes, a thing that has a parachute. So that is the smallest possible payload that we could have. We're going to try and design this in probably the most lightweight way. And eventually we could go ahead, and once we have the code written and we've kind of proof of concept all of this, we have something that lands and returns, then we can expand out what returns to actually perhaps include some crew. But if we think about what actually has to return, we know that when we're designing a craft, we'll want some batteries, we'll want some solar panels, we'll obviously want a KOS CPU, but none of that actually has to return. All that we care about is that the science experiments return, really, and the fact that the probe core returns is really just a matter of it's something small that can have these things attached to it. So I'm going to go ahead and stick on a couple of sciencey things. Let's say, we'll take you. Actually, since we've only got... Oh, oops, I have symmetry on. I shouldn't have symmetry on. I'm going to grab you. I'm going to grab you. And let's see. Oh, the other thing that I didn't mention, and let's put symmetry on here as well, is that I want this to run without us uploading multiple scripts. So we've done some stuff where we've landed. We haven't done a full land and return, but a lot of the stuff that we've done has relied on us just kind of setting up maneuver nodes with the mouse and then just being like, now you can go. And that's a little hand wavy. We want this thing to be really kind of automated. It should be able to get out there and come back, and to ensure that we're not even going to put any antennas on this thing. Now that's a little risky, but it's going to keep us honest as far as what we want to return. So here is my proposal for what our return payload should look like. And of course we have to actually test this. That's step one. Whoops. There we go. Okay. I'm using a different mouse, which is throwing me off. So how do we go about testing this? Well, if this is the thing that's going to return, we don't actually have to write any script for this. I'm just going to grab stack decoupler, and we can put on, let's see, there we go, the flea booster. This is going to get it up, and the only thing that we need to add as well is our auto stage stuff. So I'm going to grab an altimeter. I'm actually going to put, so one of the things about these altimeters is that they weigh a lot, or there's something weird with their their drag profiles. So I'm actually going to have these on symmetry, even though we only really need one, because we're going to end up having these stage at the same time. So we're going to do that. And I'm just going to set, we wanted some amount of meters. How high does this go? 1,000 meters? Yeah, that's fine. And only trigger on descent. So this will just stage once we get to 1,000 meters descending, which is good. And this will do the exact same thing, but at that point we don't care. So we're going to put this out on the launch pad, and then it is going to, we're going to hit the spacebar once, and put 2 of these on here. And we're just going to make sure that this thing will go ahead and land. So I'm just going to move our staging down here. You know, very, very simple craft. Let's go ahead and fly it. Athena Mark 1, payload test, ready. All right, so we're here, and we don't need to do anything. All right. And yes, I am now running these. I've decided to run the KSP stuff on my regular machine. Oh, you know what? This is... Yeah, so you may be seeing some frame rate loss. I apologize for that. But hey, the point is we're testing these graphs anyway. I'm nervous about... Well, okay. That's fine, I guess. Okay, why is this... Yes, I reinstalled some of the extensions and now they're covering up stuff. Okay. So it is still going up. How high up does this thing get? All right. Up to 5 something. All right. Yeah. Yeah, I did a fresh install to make sure that when I ported stuff over, things were good. But let's go ahead and run out the clock. No connection. That's fine. And this shouldn't do anything until... Oh. Okay. So now we see a little bit of an issue. And that is that even though this thing is rather heavy, we're pointed straight down. And what that means is that even if we were to decouple this, we would be pointed straight down as well. Now I suspect that that's... Okay. Did I just... I thought it staged. Did it not stage? Maybe it didn't stage. I thought I heard something stage. Well, no, we're still at... Oh, there we go. Staging. What? Okay, there you go. Yes, so when the parachute's open, of course, this thing comes down just fine, and it's going to come down... You know, we're already going very slowly, so that's great. But it is still a bit of an issue in that if we are coming back from, say, Minmus, and we enter the atmosphere with this parachute pointing downward, that is going to be an enormous problem. So we're going to have to look at some alternative strategies. So I'm going to go ahead and revert this. Well, we'll go ahead and let the whole thing land, and then I will see you in the VAB. Alrighty, so back in the VAB, we're going to have to do some modifications. This payload on its own is not going to work because it is going to come down headfirst, which will cause some issues. So what we have to think about is how do we actually, and if we turn on the center of mass and zoom in for a while, I think it's the center of mass that ends up actually determining this more than the aerodynamic profile. But yes, it's a little top heavy. So we could start tacking on some stuff here. I'm a little nervous about how that would work in practice. So what I'm instead going to say is we just need to use a heat shield. So let's look at, where is that now? So that's in aerodynamics, which makes sense. Now the one unfortunate thing is that there's not a probe core heat shield. The smallest that they have is the 1.25. So this is what our payload has to look like now. Not some wonderful tiny little thing. It has to look like this. But now that we know that it has to look like this, we can do... it means we can probably get away with sneaking on some more science, right? I mean, since we've got to do it anyway. The whole idea is that we would return the smallest amount possible, and then we could, detach everything and not have to worry about, what about these solar panels and making sure that there's battery power for stuff as it's coming down. Well, now we know that we actually have to put stuff on here anyway. So why not we'll add on the KOS CPU. Go ahead and tack that on there, because this one is smaller. If we put this in some sort of thing that was designed to burn up in the atmosphere, that'd be a little weird to have some sort of decoupler under there and then go back to the smaller thing, because everything below here is probably just going to be 1.25. So we'll go ahead, we'll put that on there. Actually, let me make sure that I tweak this so that for now we're going to not use a boot script, and tack that on there. Yep, there's still some clipping with that part, but that's fine. And let's look and we'll see. Okay, let's add some mystery goo, because we can, and now this should be mostly protected anyway. So we could radial these, and let's see if we, I'm not gonna, whoops, no. See, this is why a lot of times the ship construction is not part of these episodes. I'm gonna go ahead and single that, and single that over here. And let's think, is there anything else kind of worth, well, we've got to put this back on. It's just asymmetric is all, which is frustrating. Okay, we'll just put you over there off to the side. Is there anything else that's worth kind of tacking on here? No, I think we're fine. We could obviously put some communication stuff on here, but I really want to avoid that because I want us to force ourselves to write the script in one. And I think actually I'm going to go ahead and, just because makes me a little nervous. Oops. Is that cheaty? It's not part clipping, but yeah, okay. I'm going to say that that's legal. Alrighty, so now we have our new payload. But of course we want to test that this thing will come down and land properly. If we throw up our center of mass, okay, now we can see this is looking a lot better. This is bottom heavy, which means that this should be the side that re-enters, but of course we'll want to run a mission to test that. So let's go ahead and bring this up here. And because this is a heavier thing, I'm going to say let's get a heavier booster. We need to get ourselves a decoupler first, of course. Oh man, those things are heavy now. Yep, all right, and solid fuel booster. And bring you down. There you go. And yeah, we can get rid of all of that. You can go away. We're going to want to do some of the same stuff here, in that we want to we're going to do the same auto staging stuff. So let me go ahead and grab those from utility, altimeter. We're going to put these somewhere here. I mean, so you'll notice that even though we have the CPU core now on our craft, we're still not relying on, we haven't figured out batteries, we haven't figured out solar panels, any of that, because the reason is it doesn't have to survive landing. None of that does. By the time we're re-entering, we're going to rely on this craft to bring itself down safely on its own. Okay, so what I'm going to do here is, I'm not going to use meters, I'd like to use kilometers. Yes, kilometers. And 25, okay, 25 is the lowest that you can do with kilometers. That's fine. And actually, I don't care if we're going up or down, I think, at that point. Well, actually, I suspect this is going to get, let's say 75 kilometers. This thing is going to make it to space, I suspect, possibly. I may be wrong. On a suborbital flight. Not, certainly not going to orbit. Let's throw some winglets on here to make sure this thing remains somewhat stable. We'll put 4 of you on here. Does that sound good? Yep. And okay, so we've got that, and then we'll have these. And of course, now I want to make sure that I also tweak down this minimum pressure. Well, not tweak down, tweak up. Let's say 0.55. Yeah, perfect. So that way this thing will not deploy super early when we are likely going way too fast for that to be a smart idea. And I think we are just about ready for Athena Mark II. We don't need that many. Thank you. I appreciate your zeal, though. Bring you down. And okay, so let's just double check our staging. Nope, this needs to go in here. So we'll go ahead, we'll launch this, and it will go pretty much straight up, and then once it gets above 75, it'll come down, and we're just trying to see, does this thing make it back in one piece? So this is Athena Mark II. Let's go ahead and save that and launch. And it is a windy day here at the Kerbal Space Center, looking very good for our testing. We are going to, staging is good, so let's hide the UI. And let's go. All right, all systems are nominal. Nope. Slightly less nominal. All right, we're experiencing some minor. Well, all right. You know what? I mean, by the very ambiguous criteria we set for this mission, it looks like it's probably going to be a success because this thing is coming down safely. Of course, we don't particularly care if it orients itself correctly when there's a parachute trailing out the back. Alrighty, so that one, we will have to call that a mission failure and figure out what exactly caused that staging to happen. I'm going to have to go back and check those auto stagings. Aha, okay, here we are. Yes, this one did not get updated. So this one, yes, these did not stay. I thought these, usually when you have radial symmetry stuff, and you tweak them, the tweaking will remain. Did not in this case. So yes, we had a bad hardware autostage disaster. We'll go ahead and run Mark III. Well, we'll call this Mark II. We'll just say that we had a scrubbed Mark II mission and run Project Athena again. And another lovely day here on the launch pad. We are off. Hopefully, the engineers have fixed their previous issues for Project Athena. Project Athena, by the way, Athena being the goddess of mathematics, which is brilliant. And at this point, the engineers are scratching their heads, and something else is occurring to them. And that is that this thing may, our test bed may be a little over-engineered for our goals here. Okay. Yeah, we're going pretty fast and through the very thick part of the atmosphere. Yes. At this point, engineers are disavowing any responsibility for such issues. But okay, that's pretty impressive, actually. The craft actually. You know what? So Mission Control, obviously monitoring the situation, despite the fact that there's no telemetry coming back from this vessel, has decided that this actually will make a decent test craft despite the lack of Parachutey-ness, based on the fact that, well, it's still mostly fair, right? I mean, we're still talking just whether or not this thing comes down the right way. We're going to assume that if it does, then it will. Let's go ahead and take a look at the map view, and yep, we are making it out into the vast reaches of space, and we'll cross over that threshold, at which point it should, there we go, it is staged, and were there a parachute, it should indeed attempt to use it. So now we can at least track whether or not this thing comes down bottom first, which is the goal. So let's go ahead and do some time warping, traveling at very high speeds. And of course, maybe not the fairest test because we were, well, okay. So we've got a little bit of wobble. At the very least, we know if it flipped now, it would have flipped without the parachute as well. But no, it does seem to be doing pretty well. Can we take a look at, all right, I'm not seeing any heating issues there. We are coming down very, very, very fast and straight down. So this is a good stress test. If we check our ablator, look at that. Don't even need it. Coming down incredibly, okay, lots of wobble, but okay, we're using a very small amount of ablation. Ablate faster. But of course, this test bed will not serve our needs. In future missions, we will have to replace it because it is not likely to survive its catastrophic landing, unless some strange lifting body effect happens. No, because that's an air thing. Yeah, how fast are we going? 150? Yeah, we are not, nope. Nope, this will not end well. But at the very least, we have a decent return design for our capsule. And that is good. Okay. And buoyed by their prior quasi-success, the engineers have come up with the Athena Mark III. Now, this is meant to take care of the whole problem of we don't have any power or anything at all. That this was basically just a dead rock that was capable of landing backward first. And that's really all that it could do. Now we want to actually create something that can do stuff. Now, this is ideally, unless we discover any design flaws, this is the payload that will end up going to Minmus. We extend those panels. We've got some wonderful solar panels. We've got some landing legs. We've got batteries. Not much. One of the things that's really beneficial about not having to deal with these communitrons, you may not have noticed, but these things are ridiculously energy demanding. Most of the battery power, most of the electric charge goes to powering whatever dishes, and that's why it's important to try and close down the dishes whenever we're not using them, even if that sometimes makes it a little bit risky, because we can forget to close them down again. All right, can you... Oh, no, I'm selecting the wrong thing. Come on. Right click. There you go. What? Retract? Yes, editor only. Good. So, yes, very, very simple craft. You notice that it has a fair bit of delta V because it's really not pushing around very much. And if you look at kind of maps for Minimus, this is kind of just shy of being able to get from low Kerbal orbit, landing on Minimus, and coming back. We're not going to make it do all of that. We're going to actually have some sort of transfer stage to get it from low Kerbal orbit up to Minimus, but you know, it's nice to have a crazy huge margin because we're not necessarily confident in that we'll be making the most efficient stuff to start off with. But there are two things that now we want to test, and one would be that this thing can land powered, and it does have the thrust to weight ratio to do that on Kerbal as well as certainly on Minmus, but we also want to make sure that it can perform a reasonable descent using appropriate staging. So next thing we need to do is actually get this thing from orbit. The mission for our third mission is going to be simply, from orbit, can this thing deliver its return payload safely to the ground? Because it didn't quite last time, and that's something we would really like to test, please. So, last thing that we have to do for part of the Athena mission is to actually package this up into... Come on, where is it? Oh my gosh. Okay, there we go. Yes. The protective shell. So, obviously we need both a decoupler and a protective shell. But this is the Athena payload, unless we discover any critical problems with it. And so we are going to wrap it up in a lovely little aero shell, and we need to actually get it up to space so it can commence further testing. Unfortunately, we don't have a lifter yet, so we're going to actually have to steal from prior missions, which are not part of the Athena program, and we'll test things from there. You know what? I'm gonna mess around with that aero shell, make it look a little bit nicer. But as far as actually designing the script and running the missions for our Mark III, that will have to take place in the next episode, so I will hope to see you then. Cheers.